We've looked at how to find the general formulas for arithmetic sequences, but it's also important to be able to find the partial sums of these arithmetic sequences. Remember, we already talked about how an infinite sum or an infinite series of an arithmetic sequence is not going to converge, but we do want to be able to find partial sums. These are two formulas that can be used to calculate the partial sums, and the choice of which one to use is typically based on whether it's easier to determine D or whether it's easier to determine the last term a sub n for the sum that you're trying to evaluate. So let's look at an example here. If I want to determine the sum of the first 100 positive integers, let's look first of all at the first few to develop a pattern. We're going to have 1, 3, 5, 7, and so on. We know that the nth odd number is going to be 2 times n minus 1. And if you're not quite sure how we got that, consider the second term here. 3 is 1 plus 2, which is the same idea as 2 times, notice this would be a sub 2, so n is 2 minus 1. This is a sub 4, so to help you see this again, 2 times 4 is 8, minus 1 gives you the 7. Well, now that we have A1 is equal to 1, D is equal to 2, and we want the first 100 terms, we can calculate A sub 100 is going to be 2 times 100 minus 1, or 199. We can actually use either partial sum formula, and I'm going to show you both of those. I can calculate S sub 100 using the first formula is 100 times 1 plus 2 times 100 minus 1 times 100 all divided by 2, which equals 100 plus 2 times 99 times 100 over 2, which is 10,000. Using the second formula, S sub 100 is 100 over 2 times 1 plus 199, which results in 50 times 200, which is also 10,000.